My name is Bowden Kelly. I work at Microsoft. I'm a program manager working on JavaScript tools, including Typescript, Node.js, and other tooling support in Visual Studio and Visual Studio Code. But today we're looking at specifically how to get you from 0 to 60 with Typescript in Node.js. We only have 25 minutes, so we're going to go kind of fast. It's going to be very demo-driven. If you have questions, hold them to the end, and I'll try to get them in time. If you get nothing else from this session, I want you to understand why Typescript is worth your time. There's a lot of tools out there. There's a lot of technologies these days for a JavaScript developer to consider. And if you take nothing else away, you should understand why Typescript. What does it aim to do? And we'll get to that right off the bat. I'm also going to show you how to get productive fast in whatever environment you're currently in. And then finally, I'm going to show you just a little bit of Typescript in action. So why Typescript? We think it's pretty simple. We believe that developers should be able to focus on creating amazing things. And creating is bold here because that's what we all aim to do with code. Code is just a tool at the end of the day to help us build services and products and experiences to truly wow our users. But in reality, that's not really how we spend our time. If you take every activity you do on a week-to-week basis in your development cycles, they can fall into three broad categories. Understanding code, this is reading the existing code, looking up documentation, finding bugs. Maintaining existing code, so this includes refactoring and preparing for new features, and fixing those bugs that already exist. And then finally, after you've done all of those things, after you've paid all that tax, you can actually write new code and deliver new experiences. And we found with JavaScript in particular, the larger your code base grows, the more complicated it gets, and the harder it gets to focus on creation. Is anyone familiar with Monaco? How about VS Code? So Monaco is where VS Code started. The idea was we wanted to take an editor environment and put it in the browser. And so as such, this was all written in JavaScript. And we found that as this code base hit 300, 400,000 lines of code, it became really hard to focus on creation. And we actually kind of measured. We said, how long are we spending on each of these buckets? And what we found is a vast majority of our time was just trying to understand what our code was even doing. Then we spent about 25% of our time maintaining, and then finally 5%, or 2 hours in a 40-hour work week, actually trying to build that editor in the browser. And we said, this is not good enough. We can definitely do better. What would it take? What if we could take this split and just build some tools such that minor savings from understanding and maintenance could add to creation time instead? And what would that tool look like? And it was chasing that idea that we created Typescript. Now, what exactly is Typescript? The technical definition is an optionally typed superset of JavaScript that compiles to plain JavaScript. But I've always found it easier just to show rather than tell. And so here we are in a JavaScript file. This is a random JavaScript file that we took out of a random project. And to get started with TypeScript, to see what TypeScript does, all we're going to do is add a single comment. And it's going to be tscheck at the top of our file. And what this is going to do is it's going to flag this in VS Code. And this is VS Code, by the way. If you're unfamiliar, you should check it out. It's a great editor. But if you just put tscheck at the top, it's going to flag this file and say, hey, I want you to go type check this JavaScript for me. Do nothing else. Just run the TypeScript type checker and tell me if anything looks off. And right off the bat, you see we have some red squiggles. This is actually not even part of the demo, but Z object. I guess that's a typo. My bad. But TypeScript's going to look at all these things and see what makes sense or what doesn't make sense. And in this case, Z object, they don't know what that is. And so they flag it. And in fact, it was a typo. It was a mistake, so we can delete that out. We can look at the next mistake. Argument of type, this string literal, value in read-only, is not assignable to the parameter property descriptor. And so what's happening here is JavaScript has types. It is dynamically typed, so they can change, and they're not necessarily enforced ever. But they do have types. Types exist under the scenes, and that's what TypeScript's looking at. And so if we look at this define property method, we can see that there are, in fact, types that JavaScript expects at runtime. And if we look at this property descriptor, there are a limited set of options that you can pass through. And anything that isn't in this set just is going to get ignored by JavaScript at runtime. It doesn't care. Right? And so we're going to look at this. We're going to see configurable, enumerable, value, and writable. And we can see that back in our code, we used read-only. So probably what we intended was to say writable, false, or actually true. And you see our error goes away. But what would have happened at runtime? Again, if I pass in read-only into this method, it's going to look at it. It's going to see that it doesn't match what it's expecting. And it's going to pretend like it never saw anything. And so now you have a misconfigured object. Your method may be behaving in a way that you didn't expect, and you don't even have an error to point you to the right direction where your code went wrong. And that's what TypeScript does. It points you in the right direction. Here we have another mistake where we see operator greater than cannot be applied to some function and a number. If we look at ship weight, sure enough, it's a function that returns the parse int of some text. So probably what we intended to do was call this function. But we didn't, right? And this is a common mistake. I've done this thousands of times. But you won't catch this until runtime. And in fact, at runtime, what's going to happen when you compare a function and a number? It's false. It's not an error. It's not true. It's false. And so this code is going to be misbehaving. You will never find that your shipping weight is over 100. It will always return false, and you'll have no idea why your code's misbehaving. TypeScript can help you save you from these little mistakes. But this is just JavaScript, right? We haven't done anything to change what's going on here. TypeScript is just looking at your existing JavaScript because TypeScript is a superset of JavaScript. But what else can we do with TypeScript? Well, we can start adding types. In this function, we have an email address parameter, and TypeScript's saying this is an any. And so right now, it doesn't know anything about this parameter, but we can tell it. We can say, hey, I've got this comment here that says it can be a string or a string array. So I'm going to use a js.comment, because again, we're still in a JS file. And I'm going to say this is a string or a string array. And now TypeScript knows from this js.comment that we want this to be a string or a string array. And now I can continue type checking the rest of your code with this assumption that this is what you're saying it is. And here we find a final mistake where we have misspelled trim because trin is not a function off of email address. And so basically what you're seeing here is TypeScript is just JavaScript. TypeScript is just additional tools to help you write better JavaScript, to take care of the little mistakes and let you focus on what you're actually trying to build. And so what are you supposed to take away from that quick demo? Really, you can start using type checking JavaScript today. It's very simple. In VS Code, all you have to do is add a comment to the top of your file. Using tscheck will get you started fast. You don't have to deal with configuration. You don't have to deal with config files or build setups. All you have to do is add that comment. And then you can slowly start adding JS.doc comments with types in them to experiment with what types would be like. What is it like to work with a type system? You don't have to jump in all at once. So you get it. You see you can add a type system, type checking to JavaScript, but does it really work? A lot of people think that, I'm fine without type checking. It wouldn't really help me that much. Well, for the skeptics out there, there has been empirical research on this where they took 400 code bases on GitHub. They looked at bugs that made it into production, and then they went back and applied both Flow and TypeScript to those code bases to see if a compile time type checker would have prevented that bug from ever making it to production. And they found that 15% of those 400 bugs would have never made it into production and been caught by a type checker. And so it works. Type systems work. So you saw how we can start type checking JavaScript. But TypeScript's more than that. TypeScript is a superset, and it really allows a lot more features than you just saw. And so to show you how you can convert an entire existing Express code base, I'm going to take this simple app, which is a basic Express app. It's actually a pared down sample from a quick start. And basically, it gives you a boilerplate for a Node.js Express application. It's got some basic plug templates. It's got authentication using Passport. I can log in. And it's really just a starting point. Many people use these to get started with their applications these days. And so this is what we're going to start with. And I'm going to convert this JavaScript code base to TypeScript just to show you how easy it is and some of the things you get once you do. And so as you can see, we've got a node modules folder, a node modules backup folder, because I'm very paranoid about having internet during demos. You've got a source folder, a lot of JavaScript files in here, and then your basic config files. And so the first thing to do to get going with the full-blown TypeScript is you need a tsconfig. And so I'm going to type tsc init from the integrated terminal in VS Code, and it's going to generate me a tsconfig file. And what you're going to see in this tsconfig file is a ton of options. Right? But these are all commented out. These are basically every option you could pass into tsconfig with an explanation of what it is. And so it's very useful for getting familiar with what your options are. But we already know what we need. And so I'm just going to delete this and cut straight to the chase. We're targeting Node, so we can use ES6. CommonJS is fine. We want to use allow.js, and what this is going to let us do is pass both JavaScript and TypeScript into the compiler, and I'll show you what that means in a second. We then want a out directory, and we'll call this dist for distribution. And then finally, we want a module resolution to be Node. And this is just going to tell the TypeScript compiler, I'm in a Node application, I'm targeting a Node environment. You should do module resolution in the same kind of way that I would expect in Node. And the last thing I'm going to do is I'm going to include my source file. As you see here, I have a source directory. And that will basically set the route in which TypeScript consumes source files. And so now when I run TSC, which invokes the TypeScript compiler, you will see that I made a mistake. Oh, you're right. Thank you. So this is just a globbing pattern, and I reversed that on accident. So we're going to run it. You're going to see we now have a dist folder. Inside this dist folder is the same thing we put in. We just passed in JavaScript files, and we got out JavaScript files. And you'll notice these are exactly the same, which is good. So we can now convert. We have our compiler set up. We can now convert our first file from JS to TS. And once we've done this, we can now write TypeScript as we would expect, where we can add type annotations inline to functions. And then when we call the function, if we don't pass in the correct type, it will complain. Right? We are now in a TypeScript file, a TypeScript environment. The compiler is checking this by default now. But notice the rest of my files are still JavaScript. So I can now run TSC again, and it will take all of the TypeScript files in this source file, convert them to JavaScript, and we'll take all of the JavaScript files and just basically pass them through the compiler, and we'll put them all in my distribution folder so that I can still run my app. So now I can still do Node, and this time we'll go from dist, and we'll put server, that's not it, and fire it up, and you'll see that it is, in fact, still working as we'd expect. Nothing has changed. So this is the part where if you have a large project, you might want to go file by file, one file at a time, convert it to TypeScript, do your work, and make it the conversion in a piecemeal fashion. But because this is a small project, and there's only a handful of files, I'm just going to go ahead and convert these all to TS, just so you can see what that conversion is going to be like. And so we're going to run TSC again, and this is where you start to run into the first kind of friction from converting. Right? We're going to get a couple of errors, and you see a bunch of them are cannot redeclare this block-scoped variable passport. Right? And basically what's happening here is if we go look at passport TS, we can see we've got squiggles on our imports, and this is a kind of complicated subject. If you dealt with modules in JavaScript before, you know that it's a pretty deep rabbit hole. And so I'm not going to go too in-depth here, but basically this code is written in require using CommonJS. What we need it to be is an ES6 so that the TypeScript compiler can understand it and then return it back to CommonJS. And so to do that, we can just use this handy regex that I have in this sketchy unsaved notepad file. And what this regex is going to do is it's going to take all of our import statements and convert them to the ES6 import star syntax. And so when I do that, you'll see it highlights all of my imports. I can go ahead and execute that, and it's going to replace them all in line, and I now have import star as passport from passport, and you see the TypeScript compiler is now happy. The other thing I have to do is if I change my imports, I also got to change my exports. And so we'll do that real quick too. Gonna make sure we don't change anything in jQuery, that would be bad. And all of our exports get changed as well. Now this isn't a perfect conversion. This was just a real quick regex I wrote right before this. And so there's a couple places where it doesn't do exactly what we want. For example, when we're trying to export our model, we use modules.export instead of export equals, or exports equals rather. And so we have to go clean this up by hand. But you could write a much better regex than I could and make this actually work. And so we're going to switch this to export default user. You'll see why we want a default in a while. And then we also need to switch this module export to export app. Export equals app. There we go. So now we're going to go ahead and check our problems list to see where our remaining problems are. And it looks like we've got one more error. Again, this is another module thing. Because of the way Express Validator exposes itself in their module, we have to use a slightly separate syntax for this module. This is pretty rare, but Express Validator is the one that you'll experience in a Node project, where you have to say import Express Validator equals require instead of from Express Validator. Again, kind of a nuisance, but it comes into this whole inherited module problem that we have. So now let's look at some of the remaining errors we have. And so this one will tell us that property ID does not exist on this type, which is an empty object. And if we look at this, we can see that serialized user has a full function body. And if we look at that, this is actually a DTS file that we have hiding in the project. And this is where I have to lie to you a little bit. I went ahead and downloaded all the DTS files for this project ahead of time, again, for internet reasons. But basically what happens here is if we go to our package.json, we can get the type definitions for just about every single Node module by going to @types, which is basically a community that's on GitHub that just contributes all of their own typings to a community, and we can download them by using the @types scope on npm. And so when I say @types/express session, I'm getting the DTS file for express session. And you can see I have a number of DTS files that I've gone ahead and grabbed, and all of these are imports that I use somewhere in this project. And what this does is in my Node modules folder, you will see I have an @types folder, and in here I have a DTS file for every single one of these, which contains the types, which will let me type check the code. This is really great because this is basically free value, right? Typically, when you're using a type checker, you have to provide the types for them to check. When you use a DTS file, someone has already gone and done all of the work of adding those types for you, and you just get to benefit from their labor. So that's great. But so we're looking at this and we're saying, okay, well, there's a problem here. ID does not exist on this, user, but this is our user model. This is the thing that we defined use for Mongoose, right? And basically what we need to tell TypeScript here is this is a little more specific than just an empty object. In fact, it is a Mongoose document. And so we can import document. Sorry. We can import from Mongoose document, which is a type, again, that has already been defined for us. If we look at that, we can see this is a DTS file again, and someone has gone ahead and defined all of the things that exist on a Mongoose document. And now we can say this user is actually of type document. And that error will go away. But not all of the errors go away. And if we look at, okay, we have another problem here where we're importing user incorrectly. If we right-click and go to definition on this user, we see we just end up in this file, but not on the actual user we export. And so the issue in this case is because we used a default export, we have to alias the import. So we say default as user, and then we're all better. Anyways, back to our user model. If we look at this user model, we'll add document here again, and we'll expect to resolve this error. Except in this case, it doesn't work. And that's because compare password is a method that we added onto our user model in Mongoose. And so we've added this custom method. It doesn't exist on the document, and so we need some way to extend document and say, this isn't just a document, this is a user document. And so what you can do is you can create a type in TypeScript. And so we'll export type user document, and we'll say that this is a mongoose.document and some additional stuff. And what this is an intersection type. This ampersand basically says, I have one type that I want to start with, and I want to throw more stuff into it to create some new type, which we'll call user document. And so we'll add compare password here, and we'll make it an any just for now. And when we go back to our document, and we make this now a user document. Oh, we got to import it first. Sorry. Oh, wrong place. When we now make this a user document, you'll see that our error goes away. And indeed, if we look at this user, we can see that we have the base document stuff on it, like ID, for example. But we also have our function compare password, which is of type any. And so we can actually do much better than this, because when we defined this model, there was a bunch of stuff in it, right? We have, profile, which has a bunch of strings, and password token. And so again, back to my sketchy notepad, we can grab the type and type out exactly what we want this type to be. And we'll go ahead and format this real quick. And now, when we refer to it, now that we've added, all of the properties that exist on this type, when we actually use it, when we're in Passport, we can see that we have access to all of those things. So if I look at profile, we have profile, and we can see all of the properties that exist inside profile. And so again, TypeScript is just helping you here. It's telling you what your options are, what's available. If you make a mistake and try to, do something that's not there, it's going to tell you this property does not exist on this model that you created. And it's going to give you basically the help you need to focus on what you're trying to build. Let's see. Last one. This is also an import error where we're importing user, and this needs to be a default. And with that, we should be done. We've now converted all of our files to TypeScript. We can run TSC and see that it does compile to our distributed folder, and it comes back clean. There's no errors. If we run Node on that server and we start it up, we can see that our application still works as we expect, right? But now we're in like a fully typed environment. We're not fully typed yet. We're in a TypeScript-capable environment. So we can start adding types wherever we want. And so from here on out, you can use TypeScript or types when it's helpful and ignore them when it's not. And so if we go look at user TS, this controller, for example, you can see that we have requests and responses all throughout this file where we don't have types yet. And so if we want to, we can import from Express request and response. And now we can add these types in line. And so what this does is if you look at, before we add it, if I do request dot, I get nothing, right? Our editor knows nothing about this thing. But as soon as I tell it what it is, and again, we're taking advantage of types that other users have already defined for us. If we look at this, we can see that there is really a lot of work that has been done here that we can just take advantage of right away. When we start using these things, we now get great help, great tools, great support. If we make mistakes, the compiler is going to catch it. If we just want to, write code and see what the functions do or their signatures do, you can get all of that right in your editor. And so you don't have to flip back and forth between documentation. You don't have to spend your time trying to figure out what those methods are that you can call. You can spend more time actually doing the work you want to do. That looks like that's about all the time I have. I want to call out that this is a tiny sample taken from a larger sample. If you go to Microsoft/TypeScript Node Starter, this is a repo that we maintain so that you can see what a Node and TypeScript repository looks like and look at other best practices like testing and CI and setting up VS Code with task.json and debugging configurations. All of that stuff lives in this repository. We don't have time to go over it today, but I encourage you to check it out if you're interested. Final kind of takeaways, I encourage you, if you've never used a type checker before, download VS Code, throw at tscheck at the top of your file just to see what happens. You may be surprised and find that you have a couple bugs lurking. It also may be totally clean. The worst that could happen is nothing, right? I also would encourage you to think about adding TypeScript to any of your current workflows because it really works anywhere. You can lay it on top. In about, 10 minutes, we just added it to an Express application, but you can really add it to any kind of Node project you're using today. And finally, the point of all of this, whether it's using Node, whether it's using TypeScript, any of these tools, is to help you focus on building cool stuff. Services, products, experiences for customers. And I encourage you to think about that next time you're working on a project. How can I be more productive? We think TypeScript and Node can help you do that. Thank you.